In this video, we're going to go over sections 2.1 and 2.2. Chapter 2 is about summarizing and displaying categorical variables, and we learned in Chapter 1 that a categorical variable has a response that is a word, whereas a quantitative variable is a number with units. So we can summarize a categorical variable using what's called a frequency table. Frequency table just lists the possible responses and the number of people that responded with each. So it could report the number or the count, that makes it a frequency table, or we could report the percentage of people that gave each response, which makes it what's called a relative frequency table. The table could also list both, the count and the percentage. So in this example, we have the different majors, accounting, economics, and management, and the number of people who gave each response. So now we're going to fill in an example with this Super Bowl data. And so we have a poll that asked whether people were more interested in watching the game or the commercials. And there are 40 responses from the poll listed here. We want to make a frequency table and a relative frequency table for the data. So what I'm going to do is list all of the different responses and the number of people that responded with each. So one response is that they wouldn't watch. And if I count up the number of people who said that they wouldn't watch the game, I get a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the count is 12. For the percent, I divide 12 by the total number of responses. And I can either count how many there are altogether in the table, or sometimes the problem will just tell me the total. In this case, it tells me that there were 40 responses. So 12 divided by 40, which is 30%. Another possible response is that they were more interested in the game. And if I count how many people said that they were more interested in the game, in that list, I should end up with 18. And 18 divided by 40 is 45%. Another response in the list is that they were more interested in the commercials. And counting how many people said that they were more interested in the commercials, that's a total of 8 responses. So the count is 8. Percent is 8 divided by 40, which is 20%. And lastly, there were a couple of people who said either NA or don't know. So they didn't know exactly what they were going to do or what they were interested in. And there were 2 people that gave that response. So the count is 2. 2 divided by 40 is 5%. So if I add up all of my numbers in the count column, that should add to the total number of responses. So 12 plus 18 plus 8 plus 2 does in fact add to 40. And if I add all the percents, it should give me a total of 100%. 30 plus 45 plus 20 plus 5 does in fact equal 100%. So that brings us to section 2.2, which is displaying a categorical variable. And so what we're going to look at in this section are some different graphs that show categorical variables. Graphs are important because they're able to show important features and patterns in the data that are harder to see when you're just looking at the raw numbers. So first we're going to look at what's called the area principle. So if I look at this data and the graph, I see that I have Google, 57.36%, and then the next largest is Direct, 23.34%. So Google should look like it's twice as big, a little over twice as big as the next largest category. However, if I look at these shoes, the area occupied by the largest shoe is much more than twice the size of the area occupied by the next biggest. It looks like it's about, I would say, 4 times as big as the next largest one. And so this is violating what's called the area principle. The area principle states that the different parts of the graph should be proportionate to the magnitude of the value it represents. So a common type of graph for categorical data is called a bar chart or a bar graph. Bar chart represents the count or percentage on the y-axis, and then each category is represented by a different bar. So this is the major data from earlier. We have accounting majors. That's easy to see that that's the highest bar. We have economics majors. It's easy to see that that's the lowest, and you can easily see that management is in the middle. So bar charts allow for easy visual comparisons of the different categories to each other. This is a bar chart of the shoe data from earlier, and so not as visually entertaining, but it's easier to compare the magnitudes of the different categories. So in this bar chart, it's easier to see that Google is a little over twice as much as direct because the bar is a little bit more than twice as big. When you're doing a bar chart, the bars should be the same width. And so that was the problem with the shoes earlier, is that they weren't the same width. And there should be space between the bars. So you see in these bar charts, I have a little bit of space. The two bars are not touching one another. We can also make a relative frequency bar chart. You can see in the relative frequency bar chart, the bars all look the same, so the heights are the same. What's different is the value on the y-axis. So the frequency bar chart shows number of visits, relative frequency shows the percentage. Another type of graph that's commonly used with categorical data is a pie chart. Pie chart shows the whole divided up into different slices that are proportional to the percentage for each category. So with the pie chart, it's easy to see that Google, the slice for Google is over half of the overall pie. And so you can easily see that Google is going to be a little bit over 50%. It's not as easy to see that in a bar graph. You can see it in the relative frequency bar graph because it lists the percentages, so I can see that the Google bar is over 50%. But if I just look at the frequency bar graph, it's hard to tell that Google is over 50% because it's not easy to see what all the rest of the bars are going to add up to. So a pie chart is better for comparing each part to the whole, whereas a bar chart is better for comparing the sizes of parts to other parts. So for the bar chart, I would use that to compare the categories. Like I can see that email is more than Bing, which is more than Facebook. Pie chart is easier to see what fraction each is of the total number of visits. And again, we're talking about categorical data here, so you want to have categories, and you also want to make sure that your categories don't overlap. So each visit in this case is only going to fall into one of these categories. So we're going to make a bar chart here for our 40 Super Bowl responses. Now, when you see this on the homework, they're not going to have you actually make bar charts or pie charts in MyStatLab. These are going to be multiple choice questions. We are going to be making charts using Minitab. That's going to come up starting with our first data analysis assignment next week. But for right now, for the homework, it's going to be pretty easy. You're just going to pick the correct bar chart out of some examples. So we're going to practice drawing these by hand, which, like I said, you're not really going to have to do a whole lot of, but just to kind of refresh your memory. So I'm going to have my different bars down here. Won't watch. We'll have a bar for the game. We'll have a bar for the commercials, which I'll abbreviate, and then we'll have a bar for NA. And then I'm going to put my number of responses along the y-axis. Kind of hard to write sideways with this thing. Okay, that's good enough. Number of responses. So in this case, because these numbers are pretty small, I can make each box just one response. So I'll go to a different color here. Won't watch, that should be 12. And then I'll make this bar 2 boxes wide. Color it in. So all my other bars should be 2 boxes wide and there should be space in between. So I'm more interested in watching the game. That's 18 responses. So I need to count up. Draw that in. Commercials is 8 responses, so again leave my space and make it the same width as the other bars. And that's 8. And NA don't know, that was 2 responses. And you don't really have to worry about this when you're doing the graphs on the computer, but I always want to make sure that my axes are labeled here. So that people understand what my graph is actually showing. So that's how you make a bar chart.